there's several papers and there's several really detailed papers where they go through the phylogenetics of the issue and all the different species in the biological world that have lost their ability to synthesize vitamin C. And a lot of it has to do with common environmental stressors and triggers and reasons, basically. This one is just a simple breakdown in the abstract, but they point out here we review the genetic bases behind the repeated losses in the ability to synthesize vitamin C and their implication. They also point out that this ability has been lost. That specific gene has been broken in a number of bird species, bat species, guinea pigs, primates. Obviously, the argument is us, fish, so on and so forth. So my point is there seems to be a lack of purifying selection on this gene, probably because we all live in a world where we can get a lot of vitamin C from our diet. And so over time, that gene is not conserved. It's not subject to purifying selection because, okay, it gets hit with the deleterious mutations. Well, you know, we can still survive. We can still have progeny. And we don't necessarily need that. It just means we're going to have to take more vitamin C from the environment. But the reason why our GULO pseudogene would be broken in a similar way to the chimpanzee GULO pseudogene than, say, a bat or a fish or a guinea pig, I think is pretty obvious, which is because humans and chimpanzees share more in terms of morphology, anatomy, physiology, and genetics anyways. And so our GULO pseudogene probably looked very similar at creation or at the flood. It looked more similar than if we were to bring in, you know, a bird GULO gene. Okay, so yeah, it's going to look more similar. And so it's going to break in a more similar way than a bird GULO gene broke. Does that make sense?
No.
Well,
why do you think that the pattern of the breaking is going to depend on what? The diet, the function? What are you saying? Why would the pattern of breaking depend on any of that? Like the actual location in the gene where the mutation that breaks it occurs. Why would that be shared across different created kinds?
That's a fair question. Okay, let's say you have at creation, but I think we should start with the flood. If you have humans and then whatever the chimpanzee bonobo archetype was, okay, if their gene was still intact, if it was still producing vitamin C, as a matter of fact, it may not have by that point. But here's a working hypothesis, okay? Their gene for producing vitamin C would be more similar in genetic content and sequence than the chimpanzee, human, and let's say a pig or a fish, okay? And so the reason why these genes are subject to breaking down and they're not subject to purifying selection is because of the environment. Because we as humans, we intake a lot of vitamin C in our diet. Chimpanzees do as well. Maybe we intake vitamin C in different ways, but that doesn't stop the fact that they're breaking down for the same reason, which is because we're getting vitamin C externally. So that gene doesn't have to be preserved by selection. And so when it breaks in a similar fashion with humans and chimps. But because the gene was already very similar, it also broke in a similar way.
But wait.
I mean, this is the very basis for practicing medicine on mice before you stick it in people. It's because they do.
No, it's not. Okay, wait. You agree, Donny, that there are multiple locations in that gene where if a mutation happened in that location, that gene would be broken. There are multiple locations where that is the case. So why is it that between different created kinds, that the location where the mutation occurs is the same?
Because of mutational hotspots and also areas in the genome that are not subject to purifying selection, such as the GULO pseudogene. We're calling it pseudogene now because it's probably broken, right? Before it was just a gene, a working gene. And so it's breaking in a very similar way But I've got a whole slideshow here, and I'm trying to find it. Feel free to speak as I find it, where your favorite geneticist, Dr. Jeffrey Tompkins, he looked at primate GULO pseudogenes, and they're not identical in sequence. There are some differences there. You know, they're not just 100% similar. And so they could have broken in slightly different ways, but still in more of a similar way than, let's say, a pig or a fish gene for synthesizing vitamin C. Go ahead, speak to that a little bit while I find this.
Well, yeah, I think you're making my point is that, like, when you do a comparison across multiple species, the similarities shake out in a nested hierarchy predicted by evolution, even for like broken pseudogenes or ERVs or like lots of these more unconstrained regions of the genome. That's the whole point that we've been making this whole time.
With vitamin C, I doubt it. You might have a hierarchy within, you know, let's say the great apes. If you want to include humans, you would say humans are a human great ape. So you might have the vitamin C pseudogene is more similar between humans and the great apes than between any other creature. But once you get into like fish and bats and guinea pigs and pigs, we don't know if there's a perfect hierarchy there. It could be all over the place. What do you think? There might be a hierarchy within primates, but we don't know that that extends into the entire biological world.
Yeah, I find it pretty unconvincing that like the GULO pseudogenes would be broken in the same spot in every species.
They're not broken in the same spot in every species.
Then if they're broken in different spots for the primates like us versus the other species, then that would be a nested hierarchy pattern. Because
again,
we would be more similar, our GULO genes would be more similar to the other primates in the breakage and less similar to more distantly related species in the actual breakage, not the actual like sequence of the GULO genes. We're just talking about the mutations that have occurred in that gene.
I just feel this argument is, it's kind of a desperate argument because we understand, I mean, right here on the screen, degradation of the GULO gene in a wide array of animals or mammals and birds. It's a common occurrence. So who cares if our GULO gene is broken in the same way as a chimpanzee GULO pseudogene? What does that prove? It proves that both genes broke, and we both live in the same world, and we both intake vitamin C externally from the environment. And so if other creatures in the biological world experience their own independent breakages, then why couldn't humans and chimpanzees? It seems agnostic to in the wintertime.
No, okay, look, it's an exact example of a nested hierarchical pattern in a non-constrained gene region.
But again, the human and the chimpanzee share more already in anatomy, morphology, physiology, and genetics than a human, a chimpanzee, and a fish. And so of course, that pseudogene is going to look more similar between a human and a chimp than if you bring in a pig or if you bring in a fish. I don't see why this is a problem. Before you speak, T-Rock, and then you speak as well, Grayson, this is Dr. Tompkins' analysis. I don't know how accurate it is, but he points out that when he compared the chimpanzee and gorilla, you know, the certain, the 28,000 and so on bases of GULO region, is only 84% and 87% identical to chimpanzee and gorilla. So he's pointing out at least that it's not like we have this identical GULO pseudogene between humans, chimpanzees, bonobos, gorillas, orangutans. It's not like it's exactly the same. There's some differences there. And maybe that's because of separate ancestry. Go ahead, speak to that a bit.
So if we stop talking mutations for a minute and talk instead about dietary common sense, you can kind of analyze this from the opposite end of the spectrum. Instead of talking about mutations and genes that are broken, you can instead say, okay, if I can eat vitamin C and get a benefit from it, and a chimp can eat vitamin C and get a benefit from it, and a rabbit can eat vitamin C and get a benefit from it, it's obviously that the chemistry of vitamin C is doing something very similar in all three organisms, despite them being vastly different to each other. It can't be fundamentally different than how deleterious mutations work. It's all chemistry. And so to me, it's the fact that you've got some sort of perceived hierarchy in broken genes, it's got to follow suit that our food supply does the same thing for us that it does for the other animals.
Yeah,
in a beneficial way.
How is that relevant at all to what's being discussed?
Because instead of talking about fundamentally bad mutations, what we're saying is, in order to build a healthy cell has its DNA arranged properly. In order to build a healthy cell, you eat healthy food with healthy chemistry. And it does the same thing in that direction. And why wouldn't it do the same thing in the opposite direction? If you substitute a healthy diet for an unhealthy diet and break something, it should fundamentally follow the same pattern.
No, that does not work, man. That's not how any of this works in real life.
Yes, that's exactly.
But Grayson, notice this. It seems that this GULO gene degradation, the one found in humans and chimpanzees, it occurs, we already know this, we agreed, frequently in mammals and birds. But looking at the genotype, looking at on a genetic level what's going on here, where we get it, they're not producing vitamin C. Okay, what's going on with the details of the GULO gene itself? And the events typically are associated with complete or partial loss of exons, these protein coding regions here. So this indicates that the gene may be predisposed to the effects of genetic degeneration. And so if it's the same thing genotypically that's occurring widespread in the animal kingdom, and within all those creatures,
I want to address this.
Yeah, go ahead.
Okay, so again, this is obviously a biased source. We know it's from Answers in Genesis, but moving beyond that to what it actually says and what it leaves out, which is very, very important that it leaves out here, is the pattern of breakage. How is this breakage actually occurring? Where are the mutations that are causing this breakage in the GULO gene? They completely ignore that.
No, he goes into it in detail over here. I showed you. The 13,000 bases upstream of the human GULO region correspond. He goes in, it's only 68%, 73% identical to chimpanzee and gorilla. He goes into the 6 exon regions. Have you read this specific paper at all?
How is that addressing it, though?
Because he's showing that all the GULO gene, also the bases upstream, the bases, around it in general, they're not like they're identical. It's because the way you evolutionists frame this argument, it's like, okay, we've got homology. You got this pseudogene in humans, pseudogene in chimpanzees, and it's broken in the exact same way. It's literally identical. It's almost like if we had 2 essays and there was an identical mistake, on page 3 in one and page 3 in the other. That's how you're framing it. But when you actually look at it and all the details on on the genotype, then there's also differences. It's not like it's broken in exactly the same way. It doesn't
none
look
of this
identical.
is saying that, though. I feel like you're equivocating what's on this screen right now to saying that they're broken in different ways, which it absolutely doesn't say anything of the sort.
Are you saying
they're not talking about the mutations that broke the gene in this analysis?
Right, he's talking about the bases upstream, the surrounding region,
yeah,
all the details of what's going on in.
So they're not talking about where the location of the actual mutations that cause the breakage are. They're just obfuscating it by talking about other metrics of just looking at the total similarities. Nobody's saying that these are identically similar in the whole gene sequence.
Right.
What's similar is the location of the mutation that caused the break.
I just find it funny that now, after we've discussed the unconstrained regions and the hierarchies that supposedly shouldn't be there, if young Earth creation is true, now we're just focusing in on just one pseudogene that may or may not be representing a broken gene. It probably is representing a broken gene, or maybe humans never actually had a gene to produce their own vitamin C, because again, from the young Earth creation starting point, Adam and Eve are thrown into a garden with plenty of fruits, plenty of vegetables. You got the seeds as well. And so why do they need a gene to produce vitamin C? Maybe that gene is there for another function, and maybe whatever that function was, maybe that's been degenerated over time. I don't know. That's a prediction. Maybe it needs to be tested. But worst case scenario, even if it is a broken vitamin C synthesizing gene, who cares? All kinds of creatures in the biological world experience mutations and degradation of that same gene independently, not even related to ancestry. But the reason why the chimp and human is more similar in its breakage is because they're more similar anyways. It's not a surprise to me, but anyways, go ahead.
Yeah, I just don't think that logically follows. Like, just because they're similar, if you actually look at the probabilities of where such a mutation that could cause a breakage could occur, you can still calculate the probabilities. It's not going to be 100% that you're going to get the same in each species. And so for each species, you'd have to calculate the probability of that mutation occurring in that location, and then multiply it by all the other species that you have the same breakage location in. And that lowers the probability each and every time, to the point where I don't think it's statistically going to be very high that we get the outcome that we observe today.
It's not.
So let me
It's
ask
just
you a
it's
question
one
real
gene.
quick.
I don't know why this is coming down to it's one gene that produces vitamin C, and it broke in humans and chimpanzees because we're getting enough from the environment. So it broke in the same way. I don't know why this is statistically implausible.
Let me ask a question real quick. Go ahead, Jackson.
Oh, I just said I don't eat any fruit. I don't get enough vitamin C. I was just making a joke. Go ahead.
See, now, Jackson, you would benefit from that GULO gene being turned back on and working for you.
So let me ask a question, because I don't really know the answer, but it's my understanding that like dogs do synthesize their own vitamin C, right? Is that correct?
Not sure.
You're not sure. So I guess my point here, though, I'm going to assume for the sake of argument that it is true, because I think that is the case, that dogs synthesize their own vitamin C, but people don't. So I guess what I'm saying is I would look.
Yes, they do. I just looked it up.
Okay. I would look for a trend among omnivores or carnivores to see if there is a trend specific to certain dietary.
If you want,
leans.
I can show you a paper where it shows that there's no trend among like the diets of whether or not the vitamin C gene is going to be broken. I know of the paper that shows that.
Yeah, if you want to send that to me, that'd be great. What I often find is that the detail isn't quite specific enough to really put it together. Maybe it is. I've never seen this paper. I'm not trying to make a claim about that paper one way or the other. Obviously, I haven't seen it. But my point is that in humans, we've always had a heavy diet base. Our diet's been heavily based on agriculture, which means we eat, wheat and corn and tomatoes and all that kind of stuff. Whereas animals in the wild tend to go different directions. So you can have animals if they maintain a heavy plant-centered diet. I would suspect that they don't have a need to produce their own vitamin or synthesize their own vitamin C the way dogs do. Which is exactly what I would suspect with primates. I would like chimps and gorillas. I suspect the vast majority of their diet is plant-based.
Yeah, that's exactly why we can tolerate a loss in our vitamin C synthesis, obviously, because it's being made up for in our diets. So that's why that it's less constrained. That's why the mutation could happen without a huge impact on our fitness. That's why the mutation could reach fixation without having catastrophic effects, because we can substitute vitamin C in our diet. That's why this sequence is not constrained.
According to your model, when did this genetic mistake become fixed?
I don't know.
Because for us, we have, after the flood, 8 people, right? And so let's say the gene broke pre-flood, or even post-flood during that first 500 years after the flood, it could easily become fixed where every single human being has it. And now people spread out to all parts of the globe, taking that genetic mistake with them, where today every single person has it. But according to the evolutionary model, that person who would have got that genetic mistake, basically that mutation, where they can no longer synthesize vitamin C, they'd be the ancestor of all people today. For all people today to have the vitamin C pseudogene, basically, for it to be broken. That'd be a near extinction event. That'd be catastrophic.
I would hypothesize about it, similar to what you're saying, Donny, but I would hypothesize about the whole brokenness of the gene. Very different. I would say that it's probably in its natural state, because we are intended to have a plant-based diet, and it's probably lost its ability to adjust for a heavy meat-based diet. In other words, it is the way it's supposed to be, but it's lost its ability to compensate for you if you happen to develop a population that's heavily dependent on meat and with a very low dependency on plants.
Well, I know Chris Roop and Dr. Sanford in Grayson's favorite book, Contested Bones, they predict that it was never there for vitamin C synthesis, that it has an entirely different function that's specific to humans. There's been one other creationist. He put out a technical article where he actually suggested what that function might be. I don't have the technical article on me currently, so I can't remember what that function is. But that is a possibility. And from the separate ancestry starting point, if Grayson were to steel man the model, then it does kind of make sense that for humans, at least, maybe we never had a gene to synthesize vitamin C if we never really needed to synthesize vitamin C, because we're just getting a ton externally from the environment.
Okay, it's after 1 a.m. my time, so I'm gonna head out. But I will just, for my closing remarks,
your closing.
I will say that if we never had the ability to synthesize vitamin C, then I would need a sufficient reason to explain why humans and the other great apes have the breakage in similar locations for this gene. I would need a sufficient reason. So if the speculation is that this gene was never intended to synthesize vitamin C, I hear what you're saying, that there's predictions that we could find some other function for it. Maybe even some people have predicted what a possible function for it could be. I don't know. I haven't seen that. But I would need to see the evidence. I would need to see, put up or shut up, basically. I would want to see the evidence that this what looks exactly like a vitamin C synthesizer that's broken. I would need to see what the evidence is that it does actually have a function, and I would need to know what that function is. So if there's evidence for that,
before you
I'm
leave,
open to changing my mind.
Before you leave, I want to say one quick thing to wrap up the main topic of tonight. I think I'm going to retitle the show, because I think we had a good discussion on unconstrained sequences and the hierarchies they followed into. I want to give you the last word. So I'm going to say something. T-Rock, you say something. No, wait. I'll say something. Then Jackson, you say something. Then T-Rock. Then Grayson.
Donny,
let's all make
I'm
it quick.
tired, man.
Okay, fine. Before you leave, I'll say one thing, and then you can have a last word if you want. But I just want to say, I think whether it does have an unknown function, it was designed for something different, or it's the result of a mutational hotspot, a gene that's prone to breaking down, I think it's agnostic. You disagree, that's fine. When it comes to the unconstrained sequences and the hierarchies, I don't believe it's a challenge for the creationist position. As a matter of fact, if it is a challenge at all, it's more of a challenge for the evolutionary model because you have those long time scales, okay? For the creationist model, we have 4,500 years for those hierarchies to alter in light of mutations in unconstrained sequences. For much of the same reasons that you look to and Dr. Dan look to, it's not going to alter the hierarchies in 4,500 years. Like, let's get real. Mutations will accumulate, but they're not going to accumulate that many in sequences of the genome that comprise billions of a billion plus DNA letters. Anyways, so I don't think it's a challenge. I think it's been answered. That's my last word. Grayson, go ahead. You have your last word. If you wanted to add anything, then you can leave. Then we'll let T-Rock say something, and then Jackson Rowe gets the final last word. Go ahead, Grayson.
Yeah, okay. So I see no reason to assume why we would start with a pattern of nested hierarchies in non-constrained regions. I mean, that doesn't make sense to me. I mean, there's no common design principles really that explain that to me. I mean, maybe in a future discussion, you can try to explain that one to me. I don't get it. But again, as we saw with the GULO gene example that we went through, it's not just the nested hierarchical patterns in these regions. It's the nested hierarchical patterns of mutations in these regions as well. So that was the point of us going off on that side tangent about the GULO genes. Again, I don't think that your little rhetorical trick of trying to switch it around and trying to make it a problem for evolution and not creation, I really don't think that there's much substance there, but beyond the rhetoric, I do think that it's a significant problem for the creation model, and I think that it's in line with exactly what we would expect for the evolution model. So I'm just going to leave it at that. Good night, gentlemen.
Okay, Grayson.
Right.